is this different than what we've done the last couple days? How's it different? It has to equal 0, right? We're not just trying to factor it anymore, we're trying to solve it. Okay? Now, we are still going to talk about the factors because they are important. Okay? But what our goal is to solve it, to either find the solutions or the zeros. They're also called zeros. Okay? They're called solutions or zeros. And I think you'll see why in just a second why they're called zeros. Okay? But let's just say I'm just throwing you to the wolves. Okay? No, there's not any wolves here. That's just a saying. Okay? What do you think you ought to do first if this is our problem? Oh, you want to do a greatest common factor? That's the thing we should always think of first, right? Is there a greatest common factor in all three of these terms?
Yeah.
A 2x, right? So what if I factor out a 2x? What do I have left? X squared minus 6x plus 9. Any of that look familiar based on what we've been doing the last couple days? Which part?
Everything except the
Especially the trinomial, right? What could we do with the trinomial? We could factor it, couldn't we? Couldn't we take it to two binomials? What two numbers multiply to be 9 and add to be negative 6? Negative 3 and negative 3. And why can we do the shortcut on that one? A is 1, right? Remember that? You guys are acting like I'm remembering, like you're remembering what I taught you, and that makes me happy. Yay. Okay? So what I want you to realize right now is what we just found. These are the factors, right? So you need to make sure that you have read the directions to know what you're asking for. Because if the direction says factor this equation, we are done. Does everybody understand that? If it says factor this equation, we are done. But the directions to this equation, or this problem happen to be solve. Okay? Which means we're trying to find the solutions or zeros. Now, there's something here called the zero product property. Have you ever heard of the zero product property before? I think you have, but you haven't been told it's called the zero product property. It wasn't time yet. It's fine. Okay? It's time now. I want you to know what it's called because I want you to know what it does. Okay? The zero product property says that if things multiply together to be 0, one of those things has to equal 0. Because the only way you can multiply things together and get an answer of 0 is if one of those is 0, right? It doesn't matter what any other number is that you choose. If I multiply it by a 0, I'm going to get a 0. Does that make sense? That means at least one of these factors right here has to equal 0. Which one? Yeah, I don't know either, right? We have to think all of them have the possibility of making this equation up here equal to 0. So I have to find all of the possibilities that make this equation equal to 0. So I do that by setting each factor equal to 0. Does that make sense? Well, in order to solve this one, I divide both sides by 2, right? When I divide both sides by 2, I get x equals 0, because 0 divided by 2 is 0, right? Here I have to add 3 to both sides, don't I? And I get equals 3. And here I have to add 3 to both sides, and I get x equals 3. Now, I knew from the beginning that we were going to get 3 answers. I need you to know from the beginning how many answers we're going to get. So I need to teach you something that's kind of important called the fundamental theorem of algebra. Yeah, it seems a little bit more important than kind of important. I was just being a little silly there. It's literally called the fundamental theorem of algebra. It says a lot of stuff in there, okay? The part that we care about today The fundamental theorem of algebra says whatever your degree is, and what's a degree? Your highest exponent, right? Whatever your degree is, that's how many solutions you should get. So if we look at this problem right here, how many solutions should we get? 3, right? It's easy. You just look with your eyes and see how many solutions you're supposed to get. How many solutions did we get? 3. You know, some people argue about that. Why? Why do they argue about that? Because two of them are the same. Is that okay? Did I just randomly write 2 that were the same? Or did I take individual factors and solve them for 0, or set them equal to 0 to solve them, and it happened to turn out that 2 of them are the same? Yeah, so how many solutions did we get?
3.
We got 3. Does that make sense? Okay.
Good choice.
So, here's what we've learned so far. We've learned the fundamental theorem of algebra. We've learned, and what does the fundamental theorem of algebra say? The degree is the number of answers, right? Highest exponent is how many answers you should get. And what about the zero product property? We've also learned that. What does that say? We have to set all of our factors equal to 0, right? Because multiplying a bunch of things together to get 0, that means at least one of them can give you 0, so you have to figure out all of them, what the thing is that will make it equal to 0, right? Now there's one more kind of important property that I need to teach you, but I'm not quite ready to write it down yet, okay? I need to write down the next problem first. The next problem is x to the third minus 8x squared plus 11x plus 20 equals 0. Okay? Now, when I gave you the last example, I said, what would you do first? And you said greatest common factor, right? And then we did stuff we knew how to do, right? So if I gave you this problem right here, what would you do first?
Grouping.
Grouping, because why? There's 4. We need to think about this. Can you think about it with our head real fast? What's common in the first 2 terms? X squared. If I divided an x squared out, what would be left? X minus 8, right? What's common in the last 2? A 1. If I divide out a 1, am I going to get an x minus 8?
I don't like that.
We can still solve it. We just can't use grouping. Grouping is what we want to try first, because grouping is, to us, easy, right? It is easy. That's your word. You just use that word. You enjoy grouping. You are good at it. Maybe you don't enjoy it, but you're good at it, right? Okay? But when there's 4 terms, we always want to try grouping first. But there are times when grouping doesn't work. So we have to have another strategy when grouping doesn't work. And that other strategy that we're going to use is called the rational root theorem. Okay, the rational root theorem. You got it written? All right, so here's what happens. Okay? The rational root theorem says we need to take all of the factors of Q and divide it by all of the factors of P. Okay? All of the factors of Q divided by all of the factors of P. Anybody see any problems with that? Yeah. Where the heck is P and Q coming from, right? Well, how about if I tell you? Would that be okay? Oh, that would be fine? Okay. So, the last term, our constant, is Q. Guys, please don't talk. Our last term is Q. Our A, our first term, is P. Okay? So what we're doing is all the factors of the last term divided by all the factors of the first term. What has to be true for my words to work? This equation has to be in standard form, right? It has to be in standard form, which means all of the exponents are in decreasing order. right? Highest exponent first, next highest exponent, and so on down the line. And the last term has to be my constant, right? Okay? So we have all the factors of q divided by all the factors of p. Okay? Well, what are all the factors of q? 1 and 20, 2 and 10, 4 and 5, right? Now, can I argue with you just a little bit? So 1 and 20, but what about negative 1 and negative 20? Don't they also multiply to be 20? Yeah. So I have to take into account the positives and the negatives of each factor, don't I? So here's how we're going to write that. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. I just listed them all in order, right, with a plus and a minus with it. All divided by the factors of p. Well, in this particular problem, it's 1, right? But do I still have to take into account the positive and the negative? I do. So all divided by plus or minus 1. So what I have to do now is actually do the division. Yeah, you're smiling at me because that's super easy, right? Because anything divided by 1 is just itself, right? So I end up with 1, 2, 4, 5, 10, and 20. What this ends up giving me is all possible zeros. This is all the possible zeros of this equation. Now, 2, 4, 6, 8, 10, 12. 12 possible zeros. Is that a lot? Okay, so before we listed this, how many possible zeros did I have? All of them. Negative infinity to positive infinity were all possible zeros before I narrowed it down. 12 is slightly less than infinity. Slightly, right? That's just a little math joke, right? Okay. But I would rather have only 12 possibilities than infinity possibilities, right? Okay. So what we've done is done ourselves a favor. Now, what do we do with these possible zeros? Okay. Now, can I give you a hint real quick? Like, I'm going to step aside and take a quick commercial break. A hint about this. I need you to make sure you are reading directions. Okay? Number one, the directions could say, they could give you a function like this or an equation like this and say, list all possible zeros. And if that's what the instructions are, you are done. And you go to the next problem. Okay? If it says solve, you have to list all possible zeros first and then actually figure out which ones of the zeros work. Right? How many zeros should I find that are solutions here? Fundamental theorem of algebra says 3, right? Highest exponent is 3. I should find 3 solutions that work here. So, can I show you how we're going to do this?
Yes.
Is it okay if we start with 1? 1. Vacuum.
Oh.
1. Negative 8, 11, 20. Baby vacuum. What am I looking for when I do my synthetic division? How am I going to know that this is a factor of the equation? What has to end up in the baby vacuum?
Your cons? Zero.
A 0. Look what they're called. There's a reason they're called this. Because when we do the division, well, there's lots of reasons actually that they're called zeros, but one example is when we do synthetic division, my remainder is 0. That means that this is factoring in evenly, right? There are no remainders when I factor it in, when I divide it in. So let's try to do one of these synthetic division problems, and we want a 0 right here, okay? So bring down the 1, multiply, write it here, add. Multiply, write it here, add. Multiply, uh-oh. What's going to happen? Am I going to get a 0? Okay, so I stopped that one. Let's try negative 1. 1, negative 8, 11, 20. No, we only have 12 to try. Only 12. And if I were you, I wouldn't do it in a way that I had to do all 12. The only time I would do all 12 is if I was grounded and needed something to do. But I'm adult, so I don't get grounded. Bring down the 1. Multiply. Write it here. Add. Multiply. Write it here. Add. Multiply. Ooh. What did I just find? I found my first 0. My first 0 is negative 1. Does everybody understand that? Now, would you please... oh, sorry. Do you want to keep doing synthetic division? Because we can do synthetic division. We can do all 12 of synthetic division if you want to find all 3 zeros. You're good? So can I show you a way that might be a little faster than that? Okay, once I find 1, I'm going to translate this back into an equation. What does this look like when I translate it back into an equation? X squared minus 9x plus 20. To me, that looks like a trinomial with a leading coefficient of 1. A equals 1. Can I do the shortcut on this? What two numbers multiply to be 20 and add to be negative 9? Negative 5 and negative 4. Guys, if I have the factors, can I find the zeros? If I have the factors, can I find the zeros?
Yes.
I just set them equal to 0, right? If I add 5 to both sides, I get x equals 5. And if I add 4 to both sides, I get x equals 4. So what are my zeros? Negative 1, 4, and 5. Is there any reason you wrote them in that order, Matthew? Oh, you just wanted at least to greatest? That's fine. Is there a required order? There's not. Okay. Least to greatest is always nice, right? That's like nice structure to have. Okay. But guys, I need to take you back just a quick step and to say, what happens if the question is actually asking for the factors? What do you write if the question asks for the factors? Can I write x minus 5 and x minus 4? But what's the other factor? X plus 1. Are you good? Why is it plus 1? If my 0 is negative 1, that means it came from a factor of x plus 1. Because I would have to subtract a 1 on both sides to solve for it, right? Does that help? You ready for another one? Okay. 4x to the 4th minus 40x squared plus 36 equals 0. 4x to the 4th minus 40x squared plus 36 equals 0. What do you want to do first? Greatest common factors. There are some missing ones, so we need to be careful about that, right? But greatest common factor first. What's the greatest common factor? 4. If I factor out of 4, what's left? X to the 4th minus 10x squared plus 9 equals 0. Okay. What does rational root theorem ask us to do now? All the factors of 9 divided by the factors of of 1, right? Since I factored the 4 out, I'm ignoring it now, aren't I? Okay, so what are all the factors of 9? 1, 3, and 9. All divided by what? 1. So all the factors of 9 divided by the factors of 1. So I get 1, 3, and 9. Plus or minus 1, plus or minus 3, plus or minus 9. This one's nice because I only have 6 possibilities, and I'm only supposed to get 4, right? So which one do you want to start with first? 1, okay, I'm okay with that. Now what do I have to be very careful of? So what goes first? A 1 and then a 0 and then negative 10, a 0 and a 9. And the baby vacuum goes under the 9, right? Okay. Bring down the 1. 1 times 1 is 1. Adding, that's a 1. 1 times 1 is 1. Adding, that's a negative 9. 1 times negative 9 is negative 9. Adding, that's a negative 9. 1 times negative 9 is negative 9. Ooh, you guys guessed really good. Yeah, odds were in your favor though, weren't they? Okay, out of 6 possibilities, you knew 4 worked. So we did good with starting, right? So I have a couple possibilities right now. I have a couple things I could try. I could start all the way over from the beginning with like negative 1 and write 1, 0, negative 10, 0, and 9. That's one possibility. Let me show you what that does real quick. 1, 0, negative 10, 0, and 9. 1, negative 1, negative 1, 1, negative 9, 9, 9, negative 9, 0. Right? So I know negative 1's a 0. I know that's going to work. But what I could have done instead, can I show you what I could have done instead? I could have kept going right here and put my baby vacuum under the negative 9. Because if I know it's a factor of this, isn't it also a factor of this? It is, right? So if I try negative 1 here, I have 1, negative 1, 0, negative 1, 0, negative 9, 9, and 0. I knew I would get a 0 there because I got a 0 over here, right? But what does this translate back into? X squared minus 9 equals 0. Well, x squared minus 9 is called the difference of squares, and how can I factor the difference of squares? Yes, x plus 3x minus 3, right? So let's go over here and let's write our factors first. Are you okay with that? Factors. How many am I supposed to have? 4, right? So what are my 4 factors? X plus 3 and x minus 3, right? For sure. But also x plus 1 and x minus 1. Those are my factors. What are my zeros? Well, negative 1 and 1 for sure, because those are the ones I have over here. But what do I get from these factors? What do I get from this factor? Negative 3, and what do I get from this factor? Positive 3. Now, did I show any work there? Wait, I did it in my head? I subtracted 3 from both sides and figured out that my 0 should be negative 3. I added 3 to both sides and figured out my 0 should be 3. How much do I love for you to show your work? A lot, right? Is that something I'm going to be real picky about? No, I didn't even do it right now, did I? Okay, so just be aware of that. Now, I saw some of you thinking back up here that that's the trinomial, that it's similar to a quadratic where I could have multiplied to 9 and add to be negative 10. Couldn't I have done that? And I would have gotten x squared minus 1 and x squared minus 9, which both happen to be the difference of squares. and you could have gotten x plus 1, x minus 1, x plus 3, x minus 3 from the very beginning. If you notice that, I'm very glad about that, but what we're working on right now is using rational root theorem, and so that's why we went this way. Does that make sense? Okay? Like I said, if you notice that, I'm very glad. Okay? But right now, today, what we're working on is rational root theorem. What if this question was on a test? Would I care which way you did it? No, because the directions on the test said solve. Okay? And I'm not gonna, I'm not, at that point, I'm not the boss of how you solve it. I'm giving you the choice of how you solve it. Today I'm the boss saying we're doing rational root theorem, because that's something that we need to work on and learn. Okay? All right, one more example. One more example. X cubed plus x squared minus 17x plus 15 equals 0. Our first instinct is grouping, right? Is grouping going to work? Now you can tell right away it's not going to work, right? Because if I factor out an x squared, I'd get x plus 1. I'm not going to get x plus 1 here, am I? Okay? So I know I need to list all possible zeros. What are all possible zeros here? Well, what are the factors of 15? 1, 3, 5, and 15, right? All divisible by plus or minus 1. Once again, that's real nice. And I just get 8. How many am I supposed to get? 3. So I still have some pretty good odds, right? Which one do you want to start with? Which one do most people start with? 1. Bring down the 1, multiply, write it here, add. Multiply, write it here, add. Multiply, write it here, add. Huh. Good guess. Could I keep going? Yes, but when it's a trinomial, what I mostly want to try? I want to factor it. So x squared plus 2x minus 15. Can that factor? Don't say anything out loud yet. Let everybody have a chance to think. Has everybody figured out what the factors would be? What are the factors? X plus 5, x minus 3, right? X plus 5, x minus 3. So my factors are x plus 5, x minus 3, and x minus 1, right? Because that's a plus 1. I don't know what that mark is right there. What are my zeros? The 0 from here is negative 5. The 0 from here is 3. And the 0 from here is 1. Any questions? Guys, the only thing that I didn't show you real quick is if my equation looks like this. 2x to the third plus blah, 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 plus 15. And my rational root theorem says all possible zeros. So I have to do 1, 3, 5, and 15. All divided by 1 and 2. That means I would have to do 1, 3, 5, and 15. But that means I need all of these also divisible by 2. So 1 half, 3 halves, 5 halves, and 15 halves. Okay? Does that make sense? Please have a wonderful day, and I will see you tomorrow.
We don't have homework.